Hello friends, my name is Mayank Chug and welcome to my YouTube channel. So today we are starting from our first hands-on session using Notebook with Cursor IDE. So in this video we'll walk through one of the most fundamental topic in Python, data types and collection. If you are confused when to use list versus tuples and what exactly a dictionary does the video this is the video for you. We are going to go cell by cell through this notebook. I'll explain what every line does, why it is matter, and I'll also give you some hands-on exercise along the way so you can pause the video and try things yourself. So let's start. So as you can see, this notebook is having all the comments properly. In the last video, we have left from that place where the environment setup was done. So if you want to see that how to complete the environment, so that was the video for you. And then this video basically we will start working with the first notebook. So in this notebook, if you see, I have uh, before this video basically we have also do that pip install IPv kernel and linked with this video, so that this video this notebook with this notebook. So this is I have already done. And now let's start with the step by steps. So part one basically how to use this notebook. You have to do a control enter, shift enter. So those commands I have already there. It's added here in the keyboard shortcuts. So basically shift enter run cells and select next. Control enter will be the select and stay in the same cell. Let me see if I can show you. Go up. You can see if I'm doing this and I'm shifting shift enter, it is going and it is here, means here, and then you can see that this is enabled. So I can, if I'll press enter shift enter again, the next one is also execute. If I'll be here and I only do that control enter, then look, it is again and again executing the same cell and output is 6. Okay. Now also in Markdown, what will come to that. So before we run anything, I want to you to notice two type of cells in this notebook actually. The first type of is Markdown set like heading you see right now. These cells holds formatted text explanation, heading, even mathematical formulas. They are for you. Python does not execute them. The second type of cells are code cells. These are the gray background and a small bracket on on the left. When you press shift enter, Python runs when whatever is inside. A quick tip for shortcuts like I have shown you. Shift enter, run the current cell and move to the next. Control enter, run the current cell and stay on the same one. Alt enter, run the current cell and insert a brand new empty cell for you. On if you are using a Mac OS, replace control with command. And okay, let me start with the first one. Cell 1 basically 2 plus 2 plus 2 print. Basically it's just enter. And wherever you stuck, you have that ready your right hand side your agent. you can ask them. Suppose if I am doing any mistake over here, I forgot to enter that, and I'll run it, it will give me error. And in this case, what how I have to fix? The other one way is copy the cell output and just ask the agent, please fix. So it will fix that exception. It will fix the exception. Also, if you want to just ask that, okay, please let me know what's wrong, it will also tell what's wrong in the how to fix this cell. So this is a small example, but in you can easily figure it out what is the issue here. But in actual cases, it is different. So you can see in the right hand side, it is straight away giving that what is wrong in that cell. Let's see it's correct as well. You can see that it's correct. And if you ask that execute, if it's a problem is persistent and again is happening, it will also execute the cell for you. This is simple, and as it gets, Python can be used to as a calculator. We are adding plus 2 plus 2 plus 2, printing this result. When you are hitting shift enter, you will see the 6 appear below the cell. Notice there is nothing special here. No import, no setup. Python just works. This is one of the reason beginners love Python. You can start doing real things in literally 2 seconds. Now come to the second cell is basically hello world. It's always be a in every programming language, if you learn that the first program you will print the hello world. Every programming tutorial is in the history starts here, and for the good reason, this shows us that string which are the piece of text are written inside quotes. Single quotes or double quotes both works in the Python. Print is a built-in function that displays the value in your output. You will use it constantly for debugging and inspecting values. So these are the formulas. You can do it in Markdown. If you double click here, you will get that how it generate, and control enter or whatever enter you will put, it will convert into the proper format. So now come to our part 2, basically comments, variable and built-in types. Now we get into the core building blocks of Python program, variable and types. Understanding these well will save you hours of debugging later. So it's just a printing of values. A equals to 3, print 5 times A. Basically it's basically self-explanatory. If you run, so it's 5 multiplied by A, it becomes 15, and 3 multiplied by 3 becomes 9. And if the value is A value is 2, then it becomes 10 and 6. Just only printing. Now come to next cell. Basically any type of this variables we are talking. Now here we are using type, a built-in function that tells you what kind of a value Python is currently storing. This is one of the most useful debugging tool for Python beginners. A is 2 right now for our first cell, from our first cell. So type A returns integer. Let's see what it returns. So you can see that type A is return integer. Now division, okay, B is basically equal to 2.1, and this is the type. This is a float short for floating point number. Any number with decimal point is a float in the Python. In Python. Now division in Python 3, a divided by b always gives you a result in you as a float. Even if both numbers are integer, so 2 divided by 2.1 gives you 0.92952 as float. This is different from the Python 2 where integer division would give you the back the integer and chop off the decimal a, classic source of bugs that Python 3 fixed properly. Float a explicitly convert a to a float before dividing, but as you can see from the output, both C and D give you the exact same result. In Python, the explicit conversion is redundant here, but it is good to know it's exist. Part 3 collection. So, all right, now we get the really meaty part. Collection. A collection is any Python object that holds multiple values together. Python has 4 built-in collections type, and each one has a different purpose. Here is a quick cheat sheet before we dive in. List is ordered, yes. Changeable, yes. Duplicate values are possible, yes. So in ordered means it can be it can be ordered index wise, and duplicates are also allowed, yes, allowed. General purpose sequence, basically it is self-explanatory. Tuple is ordered, yes. Indexed, basically mutable, yes, no, it cannot be mutable. You cannot change the values. Duplicate, yes. First record returns multiple values. Set, ordered, no. Mutable, yes. Duplicate, no. Membership, you can uniqueness, yes. So only unique values are there. And dictionary, key ordered, it it has been added in Python 3.7 onward. So these are the characteristics for the dictionary. Let me go through again one by one. The first cell, basically creating and indexing a list. Let me run it first, then you understand much. So I have executed uh, this cell and that the other cell. I'll call this a fifth cell, and this one is basically a sixth cell. So we are in the fifth cell now. A list is written with within square brackets. Items are separated by a comma. Notice that a list can hold mixed type of string, integer, float, all the same list. In real production code, you usually keep one type of per list, but Python will not stop you from mixing. Indexing we have talked about in the above list. This is how you access individual item. Python can Python uses zero based indexing, means every indexing starts from 0, 0, 1, 2, 3, 4, like that. So first one dan is basically 0 index, this is 2 index, and sorry the uh, Okay, this is 2, this is 3, this is 1, 0, 1, 2, 3, 4, 5. So if I you can see that whatever we have printed, it is coming accordingly. 0 we have print Dan, and if you see the 3, 0, 1, 2, 3, 3 is 4. So 4 is printing here. Minus 1, the last one, last item, and second item is basically from and basically it's Python. So that's how it is printed. So simple list 0 gives Dan. You can see that simple gives 3 gives 4. And negative indexing, there is a brilliant. This is brilliant. Simple gives minus 1 is give the last one. Minus 2 will give the second last one. Now let's come to the next cell. I have already executed. Simple list equal to 3, basically it gives it 52, and then I'm not reading the code. Lists are immutable. That means you can change the values after creation. Simple list 3 52 replaces whenever whatever was at index 3 with the value 52. Simple and direct. Append adds a new item at the end of the list. After appending, length goes to 6 to from 6 to 7. Pop, basically pop 4, removes the item at the index, return it. So the list shrink back to 6 item. If you call pop with no argument, it removes and return the last item. Now go to the next one, next two. Basically, I have executed this is I am calling as cell 7 and cell 8. A neat shortcut asterisk operator on the list repeats it in quotes 5, square quote 5, and multiply by 4 gives you 5 times 4 times 5. This is very handy when you need to initialize the a known list of a known size and with a default value. One warning though, I have added a comment in the notebook about this being a shallow repeat. If you repeat a list of mutable object like inner list, all the slots point to point to the same inner object. We will see that idea come with the alias in a moment. So come to cell 8. To access the item inside the list, you use change chained indexing. Simple list 1 1. Read this as go to index 1 of the simple list, which gives you the 1 2 3. Then go the index of that, which gives you 2. This is foundation of for working with 2D dimension table matrices grids. Now come to cell 9. Let me put you a little bit up. Cell 9. Pay a close attention here. This is one of the most common Python gotchas for beginner. When you write list 2 equals to simple list, you are not writing a copy. You are creating a second name list 2. That points to the exact same list in memory. Both names refer to one list. So when you do list 2 equals to 0, you change the shared list. Look at the output. Simple list change tool even though you only touched list 2. This is called aliasing. If this is unexpected behavior, it means you probably want a copy, which is what the next cell shows. Let me execute the next cell. Copy creates a new list with the same items. Now list 3 and simple list are independent. Changing list 3 cell to multi cell Michelle, basically. If I'll change the value of this one Michelle value, if I'm changing this, meaning does not affect simple list at all. One nuisance, this is a shallow copying, meaning it copies one value one level deep. If your list contains nested list, the inner list are still shared. For fully independent nested structure, you would use copy deep copy from Python standard library, but for flat list, dot copy is exactly what you need. So pause the video and try this from your side. Create a list of 5 your favorite movie as string, access the third movie using indexing, replace the last movie using index negative indexing, append a new movie at the end. Now create a second variable point to the same list aliasing, change one of the item in the second variable and confirm that the original list also changed. Fix this using dot copy. Now we'll have to come to tuples. A tuple is a return and parenthesis. Indexing works exactly the same way as list. Simple tuple gives 42. Simple list in basically first item will give 42. Let's do it. So the third one is basically giving a 42. The key difference is immutability. You can not change a tuple after you create it. This makes tuple useful when you want to protect data from accidental modification. Think of coordination RGB values, database records, returns from query. Go to this next cell. If you try to assign simple tuple 0 in the bracket, Python throws type error. Immediately, tuple do not allow its assignment full stop. The commented out line in their intentionally. So the commented out line is there intentionally, so you can see the error message yourself. Uncomment it and run it. Read the error, then comment it back. Reading error message is a skill. The workaround pattern, convert a list, make your changes. Convert back to a tuple list, and tuple are type conversion functions. It is not the most elegant pattern, but it is a clean explicit. So for another hands-on for you, create a tuple of three number representing a RGB color. For example, 255, 128, comma 0 means in the bracket 2225, 255, comma 128, comma 0. Print the green channel value index 1. Try to change the one value directly. Read the error carefully. You use the list convert pattern to create a new tuple with the blue channel change to 200. So go to that next sets. So these assignments, if you will get time, try to do it. I will incorporate in this notebook as well these assignment for you. If you want, you can try it out. I insist to do that for you so that you understand what is happening behind the screen, how this is working basically. Now we are in set. A set is a return with curly braces. Notice we passed -2 twice, but when you print the set, it appears only once. Sets automatically eliminate duplicate. Also notice the order may be different from how you wrote the item. Sets are unsorted, unordered. They do not preserve insertion order. Don't rely on the position of the items. Now go to the next cell. Sets are not subscriptable. You cannot do simple set 1 in the bracket. There is no concept of indexing because sets have no order. Uncomment that line and see the error. What set are great for is in is the in operator. Checking membership. Water in simple set returns true or false instantly, even if the set has a millions of items. This is because sets uses the hash table internally. Lookups for are 0 o o 1 omega 1 basically. If you have learned the algorithms, it's basically o1. Go to next cell, adding and removing these values from sets. Dot add inserts a new item, removes, delete an item by value, not by position, because there is no positions. If you try to remove settings, something that is not in the set, you get a key error or use discard instead if you want to avoid the error. Now comes to dictionaries. Creating and a reading a dictionary. Let me execute this one first. Dictionary maps basically keys to values. Think of it is a real dictionary. You look up a word to find its definition, the value. The syntax is curly braces and the key value pairs separated by comma. Keys are usually strings, but they can be they can be any immutable type. Values can be anything: string, numbers, list, even other dictionaries. To access the values, you use dictionary dict in the bracket, basically key. The key is key in the square bracket, basically. Simple dictionary product in the bracket gives iPhone. You cannot use numerical index like a list. You must use key. Now go to the next cell 17. I'll call this cell 17. Updating an existing key is the same syntax as creating dictionary key name new value. If the key exists, the value is replaced. If it doesn't exist, a new key value pair is added. Python does not complain either way. Go to the next one. Simple dictionary color equals to red. Add a brand new key color to the dictionary. Dictionaries grows dynamically. You never need to declare their size upfront. This flexibility makes dictionary to go to data structure and representing real objects, a product, a user profile, a JSON response from API. Here also one hands-on is there for you. I will put it in the this this notebook before committing to the GitHub. Now comes to slicing list part 4. Slicing is how you extract portion of the list without writing a loop. Master this, you will use it continuously, specifically, especially once you move into NumPy and Pandas. The rule is list start stop. This where start is inclusion and stop is exclusion. This the item at the stop index is never included. Let me walk you through about this cell 19. Simple list 2 colon 5 starts index 2 which is 2, stop index stop before index 5 which is 66. So you get indices 2, 3, 4, that is 2, 7, 3. Notice 66 is not included. Simple list 2 colon 3 starts at 2 before stop before 3. Only one item to yes, a single item return a list. Simple list minus 5 colon minus 1 negative slicing works to index minus 5 from the and is minus 3 indexes minus 1 is 11 not included, so you get 3, 66, 119, 23. Couple more patterns knowing simple list colon 3 omitting start means start from beginning. Simple list 3 colon omitting stop means give go all the way at the end. Simple list colon colon to a third number of the steps. This gives every second item. Simple list, colon, colon, minus one, step, minus one, reverse the entire list, reserve the entire list, reverse the entire list. A very Pythonetic trick. So here also one hands-on I will give you. All right, guys, that is a wrap on the on this notebook. Let us quickly recap what we covered. Jupyter, the difference between Markdown cells and code cells, and the keyboard shortcuts you need to know. Variable, how Python binds names to values and how assignment works. Types, integer, float, how Python 3 handles division. List, mutable order, indexes to 0, dot append, dot pop, aliasing versus copy. Tuples, immutable list, great for data you should not accidentally change. Sets, unordered, unique list, perfect for membership, testing, and deduplication. Dictionary key values lookup, the backbone of the data representation in Python. Slicing, start stop steps, powerful, concise, and used everywhere in data science. The suggest practice at the end of the notebook is excellent. Create a list of students dictionary and print one sentence per student using only the data structure. That is a great exercise to pull everything together. At the end, I am Mayank Chuk. Thank you so much for watching. This is helped you. If this helped you, please hit the like, share, and subscribe